the lower two inputs for any crossing labeled, and so we'll be able to pass over to the higher two. And then when we get to the top, I guess these should have somehow been labeled. Obviously not a pure grid. When we get to the top, what we saw is that we have some word coming out of this strand and word coming out of this strand, and the relation that we get. So our first relation is that word 1 equals word 2, and in general we get, I guess this would be word 2b minus 1 equals word 2b coming from the convergence of these meridians. So in general we get a bunch of relations. The ith relation might be wi equals wi plus 1, and maybe this is for I up to b. We'll get b, right? And so this was sort of one way to describe the fundamental group. So minus the neighborhood of this beta tangle free of rank B, 2b minus 1 generators, and b minus 1 relations, where the generators are coming from, where these generators also generate pi 1 of the 2 sphere sigma minus the 2 plus. Okay. And we worked out an example of this, and then sort of what we quickly noted at the end was that now to go from having just a tangle exterior to a link exterior, we need only sort of consider the second half of the flat closure. And one thing we notice is that well, it's coming from whatever tangle we have on the bottom. But if we choose, so if we choose sigma to lie close to the minima, right? In other words, the tangle below will have very simple structure, right? So what we'll see is something like this. And we'll have this. Something like this. And you can see that the relations we get from this are pretty nice. So the first way I sort of describe this is we have this cap, these caps that go over the top that are going to relate these generators in pairs. So we'll get more relations. We'll get R1 prime all the way up to RB prime. And these are simply going to say that X1 is equal to X2 bar, X2b minus 1 is equal to X2b bar.